In question number 8 from section 3.1, we're asked to graph the quadratic function given the vertex, the axis of symmetry, the domain, and the range. Alright, so the way that we determine the vertex is that it's written in this form, f of x, which is equal to ax squared plus bx plus c. And it's in this form. The way you find the vertex is to find h, which is negative b over 2a. The way you find k, it's going to be f of h, so that will give you a vertex of h comma k. This problem, x squared minus 8x plus 14, is written in this form where you can identify that a is equal to 1, b is equal to negative 8, and c is equal to 14. Go ahead and calculate negative b over 2a, or the opposite of negative 8 divided by 2 times a. That's 8 divided by 2, which is 4. To find k, you're going to evaluate f of 4. That h that you got for the negative b over 2a, plug that back into the original and simplify. So you get 4 squared minus 8 times 4 plus 14. Okay, remember the order of operations. You want to do the exponents first. 8 times 4 is 32. 32 plus 4. And do 16 minus 32, which is negative 16 plus 4. That's going to equal negative 12. That's your k. So your vertex is hk, where the h we found to be 4, and the k, when you plug 4 into the original, we get negative 12. That's your vertex. For negative 12. Let's check. Okay, oops, I did make a mistake there. Let me just double check the work. I see that I forgot, actually, I made a mistake here. It should have been 14 when I evaluated. So let's go ahead and make that change. This should have been plus 14, and that is going to give us negative 2 for our answer, not negative 12. So sorry about that. 4, negative 2 is the vertex, and we can check our answer for that. Now for the axis of symmetry, it's going to be that vertical line that goes right through the vertex of the parabola. And this is a parabola that has a vertex, just a quick rough sketch here, at 4, negative 2. And it's a parabola that opens up, and the reason why I know that it opens up is because the leading coefficient is positive. That means you're going to have a parabola that opens up. Not sure how wide or narrow it is. We can determine that by plotting a few more points. The axis of symmetry is going to be that line that goes right through the vertex. Axis of symmetry for this one, since it's a vertical line, is going to be x equals wherever that vertex is. So that's going to be x equals 4. Check our answer. Now we're asked to find the domain. Again, as with all of these, our domain is all real numbers because you can plug anything into a quadratic function. So our domain, I'll use D for domain, is going to be everything from negative infinity to positive infinity with parentheses. Okay, for the range, you want to know how low the graph goes and how high the graph goes. The range, R for range. Now the lowest y value here is this y value, and it goes up to positive infinity on the y-axis. So our range is going to be -2 all the way up to positive infinity. The lowest y value here is at -2. The highest y value is going to be all the way up to positive infinity. And check your answer. And then we want to sketch the graph. I made a really rough sketch here using the vertex and knowing that it opens up. But to graph it using the graphing tool, you do need the vertex and you need one other point. So you can find another point, and I usually try to pick one that's close to the vertex. I know the vertex has a point of 4, -2. And we're gonna choose one other point. I usually like to try a point that's close to the vertex. For example, when x is equal to 3, because in the vertex x is equal to 4, I'm going to plug 3 into the function. So I want to find f of 3. And that's going to be 3 squared minus 8 times 3 plus 14. Is 9 minus 24 plus 14, and that is going to be -1. Oops. So we have another point that we can sketch, and that is when x is 3, y is equal to -1. We're going to use the vertex here, and this other point, the vertex here, and this other point, to sketch the parabola. Using the parabola tool, we're going to first put a point at 4, -2, and then go over 3 to -1, and you have this parabola. It opens up. Save and check your answer. Okay, now question number 9 is similar to the one we just did. We want to graph the function, give the vertex, axis of symmetry, domain, and range. Now again, this is in the form of ax squared plus bx squared plus bx plus c, and that means that we have a is -2. That means that the parabola is actually going to open down because that a is a negative number. B is 20 and c is -42. To find the vertex, we need to find h, which is -b divided by 2a. It's going to be the opposite of 20 divided by 2 times -2. So that's going to be -20 times a -4, which is a +5. Now we plug 5 into the original function to get k. F of 5, you're going to make the substitution. Okay, and use the order of operations to simplify that. And we get 8. So that means our vertex is at HK 5, 8. Let's check the answer. Excellent. The equation of the axis of symmetry. That axis of symmetry is going to be that line that goes right through the vertex. It's a vertical line through x equals 5. So the axis is always going to be x equals 5. Whatever the x part of the vertex is, if the parabola opens up or down, is going to be your axis of symmetry. X equals 5. The domain is -infinity to positive infinity, because that's, you can plug everything into this function. And the range. The range is how low the graph goes and how high the graph goes. Now this graph is a parabola that opens down. The vertex is at 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6, 7, 8. The vertex is at this point 5, 8. It's going to open down, so it looks something like this. To find the range, you want to look at on the y-axis how low the graph goes and how high the graph goes. Now the lowest that this graph goes is negative infinity, and the highest that it goes is the positive 8. So the range is from negative infinity to positive 8 with a bracket, because it does actually touch. And check. And then finally we want to graph this. In order to graph it, we need to plot the vertex plus one other point. The other point I'm going to choose a point close to the vertex 5, 8. So I'm going to choose perhaps when x is equal to 4. So I'm going to find f of 4 by plugging that in to the original equation for x. Do the calculations. Sorry, this should have been 4. And when you simplify this, you get 6. So one point that we're going to use is the vertex at 5, 8, and this other point at 4, 6. Using the parabola tool, plot 5, 8, and then plot another point 4, 6. Save and check the answer. Good job. And the last two questions I'll record on the next video.